Hello, Honors Geometry. Today we're going to look into the concept of circumference and arc length, which is the distance around a circle or partial distance around a circle. And the last topic we covered was inscribed angles and a different way to measure, now I shouldn't say circumference, but arcs is in degrees. Well, now we're not measuring in degrees. We're going to be looking at the relationship of the measure of the arc in degrees versus the measure of the arc in some kind of distance. So it all starts with this concept of pi, and perhaps you know this, but pi is the ratio of the circumference divided by the diameter of any circle. So as the circumference increases on a circle, the diameter proportionally also increases. And this relationship allows us to say, all right, well, algebraically, if I can multiply both sides by the diameter, then I can get pi times the diameter equals circumference. So now we know that if we know the diameter of a circle, or for that matter, the radius, because the radius and diameter are directly linked, then you can calculate the circumference. In all of the problems we're going to have coming up, you're going to notice that I'm going to leave pi in my answer. I'm going to have answers like 12 pi, 3 pi, because that's exact. Pi is an irrational number. It goes on forever. And I'm not going to approximate here. I'm going to leave answers exact. So from this concept, now that we have a relationship to calculate distance around the circle entirely, we want to look at a partial distance, which is called arc length. So we're not looking at the whole arc. And if I have a circle and I have a central angle with measure x, this would be x degrees. Because this is a central angle, I know that the measure of my arc in degrees is equal to the measure of the central angle. They're both x degrees. Now, if you think about fractions of a pi, well, if I were to look at a circle that were split up into 4 even parts, I can say that this is 1/4, 1/4, 1/4, and 1/4. And I know that all of these angles would also be 90 degrees, making the measures of their arc also 90 degrees. So we could also say that the measure of the arc is 90, but the measure of all of the arcs together, which is the full circle, is 360. So this fraction will be the same thing as saying 90 over 360, which reduces to 1/4. So that's a concrete example. Now taking that concrete example and generalizing, I know that the fraction of my circle here is whatever x degrees is over 360 degrees. Okay, that's the fraction of my circle. That fraction is equal to the ratio of the arc length, the part arc length, to the total distance. So if you think about, this is the part and this is the whole. This is in degrees, and now another way to measure the arc of a circle is just to say arc length. So arc length is the part, and the whole, if you're talking about distance, is now the circumference. So we have x over 360 is equal to, I'm going to abbreviate, arc length over circumference. So this is our relationship that we have here. It's often not written like this. What we do is you can multiply both sides by c to now get the arc length is equal to the circumference times this fractional part, which is intuitive by nature because you can think of any whole amount. If you have $100 and you get 1/4 of that to give to somebody else, then to find out how much that is, you would take 100 and you would multiply by the fraction 1/4 to get $25. So you're taking the whole and you're multiplying by the fraction. So the circumference, which is also pi times your diameter, and then you multiply that times x over 360, and that's going to equal your arc length. And this is often the formula that is used. But you can use the ratio if you want, or you can use this, this equation. So let's jump into two examples. The first one a bit more straightforward, and the second one it'll be a little more algebra centered. So for this one, we know that the radius of our circle is 3. And the measure of arc AB in degrees is 80. Okay, so what we know is that pi times diameter times x over 360, that's going to equal my arc length. And that's what I'm trying to find, the length of arc AB. So, do I know my diameter? Well, not directly. However, I know that the radius is only half of that, so the diameter has to be 6. So we can say pi times 6 times, all right, x over 360. So x is the measure of the arc in degrees. So I know this is 80 over 360. That equals my arc length. So here you're going to have to simplify a bit, and keep in mind this is when I said we are going to leave pi in the answer to keep it exact. You can, in fact, kind of ignore that right now and just carry it along with your answer. So in reducing these, I can divide both of these by 10. The zeros go away. And I can divide both 8 and 36. What am I doing here? 4, 2, 4, 9. So this 4 can go into both of these 2 times. 4 goes into that 9 times. And then as I multiply fractions, one thing you want to keep in mind is you can always write a number over 1. And you're multiplying straight across. So 6 times 2 would give me that 12. And then on bottom, 1 times 9 is 9. And then the pi is in the numerator, so I'm going to keep it in the numerator. And that's going to equal my arc length. But you would reduce this, because 12 and 9, 3 goes into both of them, so it becomes 4 pi over 3. So this is exactly the arc length of AB. Now looking at the next example, we're actually given the length. The length of AB is 11 pi over 3. And we know that the radius is 15. The question is, what is this measure BQA? I'm gonna call it X. Well, I know that central angle is also equal to the measure of its arc in degrees. Okay, so there's our relationship in the formula. And I know the diameter is now going to be 30. So I know pi times my diameter, which is 30, times, well, I don't know the measure of the arc in degrees, so that's x over 360. Is going to equal the arc length, which is given to me, 11 pi over 3. So now what you can do is try probably do some simplifying. So if I multiply these together and leave it as just one fraction, you can see in the numerator I'll have x and times pi times 30. In the denominator, I'm going to have 360. Now I can reduce this because 10 divides into both those. Oh, and 3 is going to divide into both those as well. 3 will divide into this one time. 3 will divide into 36 12 times. So this is going to be x times pi over 12 is going to equal 11 pi over 3. Now at this point, if you want to cross multiply, you can. Another way to do this would be to multiply by the reciprocal of the value you're trying to get rid of, because our goal here is to isolate x. We're going to get x all by itself. So I'm going to go ahead and multiply by the reciprocal of pi over 12, which would be 12 over pi. You'll see now that there'll be a 12 in the numerator and denominator that will reduce. There'll be a pi in the numerator and denominator which will reduce. So that will undo those operations. But then I also have to multiply the other side by 12 over pi. So on the left, I will now have x, which is ultimately what I'm looking for in degrees. And to reduce, the pi and the pi will reduce. I see the 12 and 3, those are both divisible by 3. So 3 becomes 1. 3 divided by 3. 12 divided by 3 becomes 4. So now what's left in the numerator is 11 and 4 to get 44. And what's left in the denominator is just 1. So that's my answer, 44 over 1, which is 44 degrees. That's either the measure of angle BQA or the measure of the arc AB in degrees. So there's our tutorial on arc length and circumference, and 2 examples that should support you in the practice that I want you to do. The practice is going to be the second page of this document. I'm uploading not only a blank copy of these notes. If you can print it out, great. If not, you can do it on a separate sheet of paper and just make your own notes. But then the second sheet is going to be our practice, and on the bottom of our practice you'll see that there's answers. So check those answers and we can go over any questions you have during our Zoom meeting. So that'll be on Thursday. And if nothing else, just email me, let me know. Hope all's well. Take care, and we'll talk soon.